All right. Good morning, everyone, and thank you so much for joining us. Really excited to have you here. For those of you that may recognize me from previous sessions, my name is Yuri Grinstein. I have the privilege of being a part of the customer engineering team here at Google. And today, I am really excited to be joined by a colleague of mine from Southern California, Tony Lobato. Tony, thank you so much for joining us. Really happy to have you.
Yeah, it's my pleasure, man.
All right, let's just make sure that we're live on YouTube, and oh yeah, there we go. Sorry, seems to be having some issues here monitoring the YouTube, but the YouTube live chat, but I'll get that going. In any case, everyone, excited to have Tony here to talk to us about Terraform. And Tony, before we get started, I'd love to kind of get a take from you as to why you think this stuff is interesting.
I think probably it's kind of key, right? Like running infrastructure and managing like really large scale infrastructure, both when it's physical and then sort of getting that migration strategy into the cloud, can kind of be a lot to wrap your head around, right? And tools like Terraform in particular, is really, really good at sort of making developers and making DevOps people and even sysadmins a little bit more comfortable with what what it means to run infrastructure in the cloud, right? So those are it really takes and abstracts away a lot of the pain of using multiple different clouds, using Google Cloud, using Amazon, using Azure into a sort of single point of view, where you don't have to go around clicking around UI. So it's just really neat in that sense.
Awesome, thank you. Well, I'd love to get a better sense of what it looks like. So let's see what you've got for us today.
Yeah. So I'm going to go ahead and share my screen here and take a look, and we can kind of grow this out. All right. So, presentation. So really want to go over some of the basics of why, right? Like Terraform and what it is. And it's a command line utility that you use at the command line. And you can use it on your laptop. You can use it running on a server. So it doesn't have to necessarily be local to you. And it manages infrastructure and services a lot like Chef and Puppet and Configuration Manager do. But instead of running or instead of managing installs or setup of software, what it's doing is it's managing the infrastructure itself, the service itself. So it's really just Chef or Puppet for infrastructure bits and putting pieces of infrastructure together. It's mostly idempotent. So when you run, just like Chef or just like Puppet, when you run something repeatedly over and over again, you're going to get the same results. Mostly, for the most part, assuming that the platform works the way it's supposed to. And then again, the key advantage here is that you're taking your infrastructure, and instead of going around like a GUI or using custom scripting and clicking through in different things, you're really managing your infrastructure as a set of structured code files, right? And I'll go into a little bit of this, and I'll give you guys some example of what this looks like. And again, this is kind of like the key thing. Normally, if you're starting off in cloud, you'll be looking at a bunch of screens like this, right? You'll create an image, create a backend, and it doesn't matter which provider you use. There's always going to be some sort of GUI or some sort of console to go through, and it's good. It can be a good experience, but once you start scaling up or you start doing things at a rapid pace, you're moving very quickly. A really big bog and a slowdown. So instead of doing this, you can now do this. So now you have this structured sort of file or files or folders that have the definition of what your infrastructure is. And this is really neat because now you can commit it to GitHub, right? Or you can commit it to a Git repository that you control, and you can collaborate across your team with a bunch of engineers, hundreds, however many engineers that you have working on infrastructure, and they all get the same sort of configuration view of the infrastructure. And really what I'm going to go over today and sort of kind of demo is sort of like a simple concept of what the folder layout structure and how to actually set up a provider and what a provider even is, right? And initializing Terraform and then creating some resources and then destroying it all and showing you how to like kind of tear down everything you're doing. Everything that we're going to be running today is going to be running on Google Cloud Platform, but there are resources in Terraform. It's fairly agnostic. You have Azure, you have AWS, you have you even have like Alibaba Cloud. There's actually a ton of different providers, as they're called, that you can sort of hook into. I think there's probably like 30 different providers for different stuff. And it's not just infrastructure. There's some other like oddities in there, like RabbitMQ, for example, and managing like the structure of RabbitMQ. And that kind of blurs the line between configuration management and infrastructure, but it's there if you want to use it. So I want to show a bit of like an architecture graph. So this is what we're actually going to be building with our demo. So we're going to do a Google Cloud load balancer, and we're going to start up 3 compute engine instances running Nginx in front of it. So, and all of that is going to be done completely from scratch. There's going to be nothing running. And then when we run our Terraform commands, we're going to end up with this automatically. So before I kick off, do you have any questions?
No questions. I wanted to point out one thing that I feel like I've already learned something from this. You used a word I've never seen before. I think it's pronounced idempotent. I'm just going to admit ignorance. So that's an awesome word that I'm now going to add to my vocabulary. So thank you for that.
Awesome.
All right, let's see. So let's see the demo, man. Let's see what you got. I'm excited to see this. I think this idea of treating infrastructure as code is something that I've heard a lot of customers, ask us about, and they ask us for recommendations. How to best automate the deployment of cloud resources. They ask us questions about using things like Chef or Puppet to do so. I've had customers ask us about deployment manager that's part of GCP. So anything that makes it easier for people to automate deployment and provisioning, anything that makes them more standardized, anything that can integrate with their existing processes, like how they manage source code, how they manage changes, is absolutely welcome. So yeah, I'm super excited.
Awesome. So let's go ahead, and we're going to look at a sort of a demo folder here. And we have 2 files in this folder right now. And the 2 files, so when you're configuring Terraform and you have a folder, you basically just have a folder full of sparse files, and you can structure them in folders and do subfolders and subcategorization. We're not going to go into that right now. We're just going to show a very sort of basic setup. And here we have 2 files. We have the provider, and then we have the web server. And these are named arbitrarily. The name of files don't matter. There is one exception to that, but for the purposes of this, it doesn't matter. You can name them anything. So in this case, we're going to look at provider. And here we are configuring the provider. In this case, we're configuring 3 different providers. We're configuring Google, AWS, and Azure as they are in the documentation for Terraform. So the only one that we're actually going to be using is Google, but I threw these in here so you can get a concept of what and how you would say do hybrid cloud, right? So you'd be able to define.
Sorry, can you just make your screen a little bigger? Just make sure the folks on YouTube can really see this clearly.
Is better?
Yeah, thank you.
Awesome, cool. So yeah, so here you can see the 3 providers that we have configured here. But like I said, there's I think there's about 30 different providers that you can do, RabbitMQ, Alibaba Cloud, like a bunch of different stuff that you can sort of throw in here. So for the purpose of this demo, we are going to be, again, building something on Google Cloud, but you'll see during initialization, which I'll show you, you'll see that we'll actually pull down the information for all 3 of these providers. Now, when you start using Terraform is just a single binary that you have and you run it. It doesn't actually contain all the providers like Google or anything else inside of it. Those are actually downloaded dynamically from the internet when you initialize a folder. So what you do here in this case is type Terraform init, and then Terraform is going to read the contents of your folder and then pull down any modules that you have configured and any providers that you have configured as well. So here it's downloading the plugin for Google, for AWS, and for Azure. And then green text, always good, right? So when you see green text, hopefully things are okay.
Yeah, you're doing this live as as people are watching. So there's always a risk that you're going to get a whole bunch of errors that.
I know it's terrifying. I was practicing last night over and over and over again. Like, oh God, this better work, please. Let
Yeah,
this work.
no matter how much you test stuff, no matter how many times you try it, when you got people watching, something always breaks. So yeah, I'm right there with you. All right, let's keep going.
All right, so here we have our initialization. So what happens during initialization, you will now see that we have a special hidden folder. And this hidden folder, generally day-to-day, you don't really need to worry about it. Just know that it's there, and it contains the Terraform plugins, the extra like binaries and the extra modules that are needed to make your Terraform configuration work. And all of that is stored in that folder. So good, we're initialized. What now? Well, if we look at our web server configuration file, here's the actual meat. This is what we're actually doing. So what we're doing here is we're defining our infrastructure and our bits of our infrastructure here. And here we have 3 different stanzas. In this case, they're called resources. So Terraform works around concepts of a resource. And a resource can be a template, a compute engine instance, an EC2 instance, just some sort of resource that it can function on. And in this case, we have a resource called an instance template called web server. And this instance template in Google Cloud terms is exactly what it sounds like. You're defining what an instance looks like, and then you make copies of this template as many times as needed to actually spin up resources. So they're not actually compute engine, but they're the template for what a compute engine looks like.
So reading this as a bit of a layman, looks like you're basically creating an instance template. It's going to be a Debian Linux machine, and then once it starts up, you're going to run a startup script that basically installs Nginx.
That's exactly correct.
Cool.
Yeah. So all of this is, and here your startup script, for example, instead of doing this, could be, hey, install Chef and Puppet, right? That's one way. There's also different provisioners. So there's Terraform has a concept of provisioners that are built in and tightly integrated. So there's a stanza that would say like, Chef, run this, that sort of configures and takes care of that at the Terraform level instead of you running a script like this. So once we have our template defined and what sort of like an instance looks like, we also define the group itself. So the sort of auto scaling group, that instance group that is a part of Google Cloud Platform in and within itself. Here we're just going to reference, and this is this line right here that I have highlighted. We're going to reference the template that we defined up above. So Terraform has a concept of back referencing or referencing other resources that are defined in a file or in separate files. The order in which you define things doesn't matter. What will happen is Terraform kind of just slurps everything up and then resolves the dependency order for you automatically. So in this case, you can see that the instance template that we're defining for this group is the resource type, Google Compute Instance Template, which matches Google Compute Instance Template down here, or up here. Then the name of it, web server, matches bottom to top. And then self-link is just a special reference saying, I'm linking to this. This is a self-link to this object. So here we have, so our group, this is it, right? This is our group and everything to actually launch the instance. And then we have our load balancer. And a load balancer, in this case, you'll notice is actually a module and not a resource. So what we're doing is we're actually pulling down a pre-compiled module that somebody else wrote to do an aggregate of different stuff. So inside of a module, what will happen is multiple resources will be built out, right? So a load balancer, for example, in Google Cloud, is actually a collection of, I think, like 4 or 5 different resources, like a URL map, a backend, a front end. There's different things that you piece together to make a load balancer in Google Cloud. So in this case, this module just kind of abstracts all of that pain away and tells you, hey, here is the module is called a load balancer, and this is, just give me the instance groups that we need, right? And some other parameters that you need to get going on it.
So this brings up an interesting question is, I think resources are probably things that are well documented. Are modules as easy to find and understand if you're trying to build something like this? Because I think if I was doing something like this, I would expect that a load balancer would be just another resource type rather than using the module command. So can you give me some sense of like how you might go about knowing when to use a module and when to use a resource?
Sure. So the easiest way to think about it is a resource is a single resource, right? So if you're doing one thing once, that is a resource. If you are doing an aggregate of something, an aggregate of resources that you want to do over and over and over and over and over again, think about what that would look like if you were just using resources. You'd be copying and pasting the resources over and over and over again. Let's say, like again, a good example is load balancer. Let's say you want to create 10 load balancers, and a load balancer comprises of 5 resources. Well, now you have to do 5 times 10 resource lines over and over and over and over again to define each and every single load balancer. Or you can make a module which kind of packages all of that up, 5 resources into one stanza, and abstract away the variables that you need. And then you now only need to put 10 stanzas, right? 10 stanzas,
Got
one
it.
for each
Yeah,
load balancer.
very cool. And then another question I just thought of, because as you're going through this, this architecture is somewhat straightforward, right? You have a load balancer and you have a single backend with an instance group. So all of that fits into a single file and it's pretty readable and it's sort of easy to manage. Would you ever recommend like splitting things out into their own separate files? For example, have one resource in this example for the instance template, another file for the managed group, and then another file for the load balancer. Like, is that considered a best practice, or do people typically avoid that?
People definitely break out their infrastructure into different files. The taxonomy of that is really up to the user. Me personally, I prefer to split things not by their resource types. So I don't put all instance group managers in one file. What I will do is I will put a concept of a service in one file. So if I have a front end web Nginx like this, for example, I would put all of this into one file. But let's say I needed some backend service or some backend API. I would put everything related to that backend API in another file. So it really depends. It's up to you on how to split it, but you should definitely split and organize that work.
Got it. All right, cool. All right, let's keep going.
Awesome. So here we have the definition for everything. So now we're going to actually, and the very first thing that you always want to do is to make sure sanity check yourself. So Terraform has a concept of plan. So you can build out a plan file. And this is basically, for the purpose of this demo, we're just going to type Terraform Plan. And we're going to see exactly what it is Terraform, what Terraform is going to apply. So green text means that it's going to create. And here we see that it's going to create the template. In Google Cloud, where it's going to create the instance group manager with all the variables that need to be done. And then it's actually, and remember how I said that a backend, a load balancer is comprised of a couple of different resources. And now it becomes apparent, oh, module, instead of writing out each one of these stanzas one by one by one by one, the module is actually doing it for you. So this is where you can actually see the effect of what the module is actually doing. We only wrote out, like 10 lines, but it's actually doing a ton of other stuff. So here we have the plan. It says 9 to add, 0 to change, 0 to destroy. This brings up a fantastic point about Terraform. So Terraform is a one-to-one view of your infrastructure. So for example, we're adding 9 things, and let's say after we actually run this infrastructure and it's running, and then we remove something from the file, from this web server file, and then we do plan again, you'll actually see items are set to be destroyed. Meaning that when you add something to a file and it's created, if you remove something from a file, you're not just removing, oh, I don't need this in the future. The next time you apply it, it's going to destroy that. It's going to undo your change. This way, it acts as a stateful machine, right? Like you're not, it's not like in Chef or Puppet where you're just removing things and then it just kind of ignores it, but what's there happens to already be there. It will undo anything that you remove from a file. So that's an important distinction for how Terraform runs. So now we're going to go ahead. We have our plan. Everything looks good. Everything is green. We are going to apply. This is always a scary step, especially during a live demo. Like, oh, this works. But we're going to go ahead and we're actually going to apply. And this will actually reach out to the API, reach out to the Google Cloud API or Amazon if you have configured, or Azure, or whatever else, and actually apply your changes. So here we can see the steps that it's doing to create everything.
And while it's running, we'll probably have a couple minutes while it's provisioning everything. Looks like, yeah, obviously you're doing this in real time, so we're all hanging on. One of the things that you just mentioned, it was really interesting to me. You described Terraform as a stateful machine, which obviously means it has to keep track of state somewhere. And I realized that while things are running, you really don't have the option of issuing more commands or anything. But I wonder if you could just briefly describe where is that state kept, and is that something that the user really has to manage and know about, or do we just trust that Terraform just does that?
So it's the answer is somewhere in the middle, like it usually is. The answer is Terraform does manage state for you, so it keeps track of what you've done and what you have applied, and you run what you undo. And the way that it keeps track by default, and which I'll show you, it's actually already done. So
oh wow, that was fast.
Yeah, it's pretty fast. Google Cloud is pretty fast. So you'll see here we have a new file called terraform.tfstate.
Yeah, that wasn't there before.
That wasn't there before, new file. And that actually keeps track of the state of Terraform, of this particular folder for Terraform. So this initialization of Terraform, here is the state. And this is the file that is sort of critical. If somebody were to, for example, clone your code that you have on Git, and they don't have the tfstate file, you put tfstate in git ignore, and it's not a part of that. Now, all of a sudden, the next person that runs these commands, they're going to see, instead of, so the next time they run plan, they're not going to see there's no changes because everything is up to date. They don't have a concept of that. They're going to see, oh, I need to make 9 changes and I need to recreate these resources, not knowing that the state is out of sync, right? So Terraform has a concept of shared state and locking. So you can do different backends in Terraform. You can configure different backends. For example,
so sorry, I'm going to interrupt you. Before we go into that, let's take a look at what it actually provisioned. So this thing ran successfully.
Yeah, it did.
Let's look at what we got.
Yeah, let's look at it. So here we have our Google Cloud platform. And first thing that we'll see is the instance template. There it is. Instance template has been created. Then we'll take a look at the instance group. Hey, there's the instance group. And let's look at the instances. Hey, there's 3 VMs that are running. We'll look at the network services for load balancing. And there it is, load balancer running. So
very cool. Wow. Yeah, it works as advertised.
Yeah, that it does.
Yeah. So let me ask you one question from the chat exchange that people are trying to understand, and specifically, and maybe this is a broader topic, so feel free to punt on it if you like. But talk a little bit about the relationship between an infrastructure provisioning and automation tool like Terraform, and then some of the tools you brought up already, like Chef or Puppet, which I've always thought of as orchestration tools. And then something like Ansible, which is, I think, configuration management. How do you do you use all? Would you use all 3 of those? Does Terraform take the place of Chef or Puppet or Ansible in some ways? What is your take on all that?
So I think that it's important to sort of, and I'm actually going to stop screen sharing here so we can sort of talk face to face here. And I always think of Chef, Puppet, Ansible, Salt. They're all the same. They all accomplish the same thing. People call them by different names: configuration management, orchestration, but they all do the same thing, and which is essentially, I will put it in the sense of they SSH into your servers and they do apt-get install or yum install and they install software, right?
Which means you need to have servers for them to act on.
Correct. Now, that's not a golden rule. Some of these tools, like Salt, for example, can actually kind of do the thing that Terraform does, but it's not hard and fast, right? Some of these tools do things differently in different ways, different files, different configuration. What Terraform does not take the place of that. So let's be clear. Terraform does not take the place of Chef, Puppet, Salt, Ansible, or anything else around that. It just augments that. It works at the level that is before these tools enact. So it actually constructs these servers that these tools run on, if that makes sense.
Yeah, it makes complete sense. So does Terraform then allow you to somehow pass instructions to these additional tools? So for example, in the instances that you just did, what would be the best way to issue further instructions to Chef, Puppet, or Ansible, or Salt to do more stuff?
So there's two different ways. You can do the startup script kind of method. Sorry, there's three different ways. There's the built-in platform startup script method, which you saw where I installed Nginx. There's the remote exec provisioner, which basically tells Terraform SSH into these machines and run these commands. And then the third one is the Chef or the Puppet provisioner, which effectively does the same thing, SSHs into these machines, and sets up Chef and Puppet given some structured configuration that's in Terraform, right? So my Chef master, my Puppet master is at this address, install Puppet and make sure it's pointing to this master, right? So it does some basic bootstrapping for you built into Terraform.
So there's like a native Terraform integration with Chef and Puppet that's available.
Correct, yes.
Okay. Awesome. That's really cool. Very much appreciated. So let's return to the topic that you were starting on before I interrupted you, which is this idea of managing state, especially across distributed organizations or teams, right? So obviously in this example, you have your own Terraform, you have your own cloud project. The state is going to be kept on your local machine because it's just your stuff. That's all there is. How would that work if you and I were working on this jointly and you to share state with me?
So what you really want to do at this point, you have a couple of options. One, you can commit your state to Git. That's sort of the crude option, and it doesn't prevent somebody from working concurrently with you, right? So you can sort of do parallel work and stomp on each other. So you have to have some outside mechanism, usually yelling at the other person or throwing like a paper airplane at them and making sure that they're not doing the work at the same time as you. Definitely do not recommend doing that. The other one is using a backend provider. So Terraform has a concept of a backend, and it will store the state in a remote location, a Google Cloud Storage bucket, an S3 bucket inside of HashiCorp's other product, which is Console. So there's different ways to like synchronize state, and all of these also support locking. So you can make sure that only one person is updating the state at any given time. This is all automatic once it's actually configured. So you just you point the backend to a Google Cloud Storage bucket, and it will make sure it will take care of all the magic for you. Beyond that, then you just run your Terraform, apply, and write your files, and you're good to go.
Very cool. Awesome. All right. What else do you got for us today?
I mean, I've got a kitchen sink if you want. let's go, man. Like that's no, just overall, I highly recommend as the cloud becomes more and more prevalent, right? Like, and it's already really prevalent. Obviously, it's been around in this concept since mid 2000s or so. But as more and more people are moving off of these on-prem massive hardware farms and they're moving into the cloud, just keep in mind that a lot of your thinking and a lot of the thinking that has really evolved over the last really 50 decades or 50 decades 5 decades I say 50 years 5 decades over the last 5 decades of what computing is, just be open to the fact that it's evolving and that it's changing, and that your concept of scaling 10 years ago is not the concept of scaling today, and partitioning work and setting up infrastructure is a very different beast. So be open to new tools. Be open to using things like Terraform and managing as code instead of going through the GUI and clicking through. You're going to save time. You're going to make less mistakes. And you're going to save money, quite frankly, when you can easily audit and look at these configuration files, right?
Yeah.
So that's all.
Good point. All right. So actually, I want to have you show us a couple more things. You've shown us how to use Terraform to create things. You've talked a little bit about how you might go about, modifying your Terraform files to make changes. So I think I'd like to see that if you can do that easily with the infrastructure you've set up. But also how you go about using Terraform to, clean stuff up. Like, if I want to delete everything that you've just done, for example, like, do I just run apply against a blank file? Or is there some easier way to clean everything up? Especially for people that are going to be using this to automate their, dev environments, to automate their sandbox and, where they want to stand stuff up and tear it down. Like, how do you go about doing that?
Yeah, so let's actually go over 2 examples for that. I've got some 2 really good things that we can go over. I'll go ahead and pop up my terminal again, and we'll do 2 different things. First, we'll make a change, and we'll do 3 examples. Sorry, we'll make a change. We'll destroy just one little resource, and then we'll destroy everything. So first, let's make a small change. What we're going to do, in this case, we're going to open up our web server back up again, and instead of 3 instances, we're going to make it 4. And we're going to make 4 servers run. So we change in that file from 3 to 4. We see the plan here, and the plan will tell us, hey, I need to change the target size from 3 to 4. So we'll go ahead and do that and apply that change. And Terraform will take care of the difference for you. You don't need to think about the current state. Terraform will always work to make sure that the state of the infrastructure will be what you have written down in these files. And here we have our change that has been applied. And we will go back to our web browser and we will refresh. And now we have a 4th instance. That's part of the group.
Wow, that was easy.
Yeah, super easy. So in that sense, we need 5 more servers, and for whatever reason you don't want to use auto scaling, or you can't because of some requirement. Change the number, hit apply, and you have another server. So fairly straightforward. So now we're going to make another change, and this one is destruction of just one part of a resource. So in this case, turns out we didn't need a load balancer. So we can do block style comments just like you can in C. We'll comment out the load balancer. Let's plan this out. You look at that. There are 7 things to destroy, which is everything that has to do with the load balancer. And now we will apply that
And
change.
I like how it's actually showing you the things it's going to destroy.
In giant red
with
text.
a minus sign and red. Yeah, make sure that you really want to do this because I'm going to tear stuff down.
That's exactly correct.
Very cool.
Yeah, so here we have a destruction of just partial. And what you'll notice is that it's only destroying the load balancer because that's what I commented out. And that's perfectly illustrating the point that I made earlier, was if you remove something from this file, it will destroy that resource. You're not just ignoring it. And that's an important distinction to make from other utilities or other things that you may be used to. This is a good thing. Just so we're clear, this is actually a really good thing. You want this because now your view of the world is consistent, right? You're not just commenting something out and then, is that still running? I don't know. It's commented, but let me go check. No, you commented it out, you applied it, you know that it's not running. So, and then while this is destroying, we'll actually go ahead and prepare to show you on the console that it is 7 destroyed. So now we will go to.
So instance group is still there.
Instance group is still there. Instances are still there. But the load balancer is gone. Now it's just asking me to create one. So we only destroyed the load balancer. And then when we're done, so we're not running up a bill and you're just experimenting, Terraform has the concept of destroy. And if I can spell, that would be good. Destroy. Oh my gosh, I swear. Okay. So Terraform destroy. Destroy will tear down Everything that it has its view of in files.
Oh, now it's asking you for confirmations. This is the first time we've seen this where it's really asking you to confirm what you want to do. So for applying, it just does it. But if you actually issue the destroy command, it really makes sure that you know what you're doing.
That's correct, yeah, because here what this will do, let's say I have an infrastructure and a definition for 100 servers and some cloud storage backends and tons of other stuff. Typing Terraform destroy will destroy all of that, right? So you need to make sure that yes, you want to do what you want to do.
Yeah.
So typing yes here, it will destroy the instance group manager, and it will destroy themselves, and it will destroy the template too. Remember, so it'll also destroy these higher level concept things, right? That you've created. So if you create like a disk or a snapshot through Terraform, it will destroy those as well when you type destroy. So it's full deconstruction.
Yep. Very cool. I know this will take a second to deprovision all those virtual machines, although it shouldn't be too much longer.
Mm-hmm.
And while it's running, I want to kind of set up the next question for you. It's coming from the chat. We have some folks asking about multi-cloud or using Terraform, in a multi-cloud environment. And I know that at the beginning, you absolutely showed us how to set up Terraform to understand that you're working in the multi-cloud environment.
Mm-hmm.
You talked about kind of the various provisioners. When you showed us the provisioner for Google and for Amazon and for AWS.
Mm-hmm.
Um, so for example, let's say I want to create something very basic. I want to stand up an instance in AWS and an instance in GCP.
Mm-hmm.
Can a single file do that? Or do I need to, have that be in separate folders? Like, how much multi-cloud can I really do at once?
So here's the really, really cool thing, and one of the main reasons I love Terraform. So yes, you can put different cloud, hybrid cloud, different things all in the same file. So let's say, for example, let's say you have some service that you're running, and your web server needs to talk to that service, but that service exists in Amazon. A lot of these resources that you see here, resource, compute instance, group manager, web server, and you see these back references like Google Compute Instance Template, web server, self-link. Self-link is not the only variable that this exposes. Every time a service or some resource is created, it has several return values, several values that were the result of the application. So for example, when you create an instance through a resource, you can reference its external IP address, internal IP address, its name, its placement, if you set the placement to like best effort or standard, like where it actually ended up putting it. And what you can do is that you can build a back reference to that. I want to run part of my infrastructure in AWS and part in Google Cloud. Well, I just build out the AWS part, get the reference to the IP address in the AWS part, and then put it into my Google Cloud parts. So you can totally just mix and match your references and kind of figure out exactly what it is. And Terraform is really good about figuring out, hey, this Google Cloud thing needs an IP address from an AWS resource that I'm creating. Let me create the AWS resource first, and then I'll go ahead and create the Google Cloud one now that I have the public IP address.
Awesome. So you could really create just like a multi-cloud deployment using a single command, and you can actually, like you just said, you can actually pass variables kind of between the two. I'm assuming that obviously you'll just have different definitions for the resources. So the way you define a GCP VM instance, for example, might be different than the way you have to define an EC2 instance.
Yeah, that's correct. So everything inside of the curly braces here would be different for a different cloud provider, right? Like the stanzas look like. So just keeping that in mind, yeah, but yeah.
Have you run into any limitations with Terraform in terms of like the specific things it can or cannot create? So for example, we have someone asking about, can you automate the creation of service account and DNS record sets? Are you aware? I mean, I'm sure there are some, but like off the top of your head, are you aware of things that, either cannot be done in GCP using Terraform or perhaps should not be done?
So yes, there are some things that cannot be done today. That's not because of lack of ability, but more of lack of time from the contributors for Terraform, which I'm one, by the way. So I do contribute to Google Cloud Terraform, the actual provider and the code for it. And we're adding features all the time, right? Like so that's the concept of constantly adding as new platform features are developed, as new things are developed. We go forward and just try to add as much as we can. That being said, it changes per provider. Because there's like 30 different providers, maybe there's something missing in the AWS one that AWS can't do, just like there might be something missing in the Google Cloud one, just like there might be something missing in the Azure one. It's just a matter of support existing for it. And the Terraform, the people who maintain it for all of the different providers, pretty open to it's all open source, it's all on GitHub. So either making a request, issue request, or even just hopping in and writing some code yourself if you're comfortable writing some code and adding some stuff. It's actually a pretty solid and easy thing to do for the most part.
Yeah. Okay. Can you give us a general sense of like what is the lag time that you've seen between like the GCP API updates and then Terraform catching up to it? I mean, are we talking days, weeks, months?
It depends on the feature and what it is. I would say anywhere between weeks and sometimes months, depending on who's working on it and the level of complexity that's involved. And it also depends on oddities or other weird things. So a great example is for load balancers. We have in Google Cloud, we have a concept of identity-aware proxy, which is this new sort of product / feature that we offer. And I actually just finished reading the code for that, I want to say about a week and a half ago. And people are using that, but it's not rolled into an official release yet because it hasn't actually been merged, right? So the code is there, but there's like things that need to be figured out in terms of like testing and other stuff. So it can vary. And that's the reality, is that it can vary.
Okay. Very cool. Well, hey man, thank you so much for taking the time to talk to us today. I really appreciate it. I think that covers all of the questions that we had in the chat. I think this was spectacularly informative. I certainly feel like I've learned a lot. I'm ready to start using Terraform in my projects. Hopefully I'll start including, TF files in all my GitHub repositories so people can have an easier time of deploying the stuff that I'm publishing, not just following my code. So thanks again, really appreciate it. And also, obviously, thank you for the work you do on Terraform. I mean, contributing to open source communities is really important. And
awesome.
I certainly
super glad to help. Yeah, hope to see a lot more pickup and a lot more usage of Terraform as time goes on.
I'm sure today will help. So thank you again. And for folks on the line, we really appreciate your time today. Thank you for watching, listening. Thank you for your questions. And hey, let us know if you have more questions on Terraform. Send us some comments on either on YouTube or on Meetup. And also send us ideas for more stuff that you want to hear about. I think we're gonna have some things coming out over the next couple of weeks, but we're always interested in knowing what you want us to talk about. So thanks again. Have a great rest of your Thursday. Have a great weekend, and we'll talk to you all next week. Take care.
Bye, everyone.